a dual wheel load. It is shared in your WhatsApp group. It be a dual wheel load assembly with 70 kilonewton load on each wheel. So here also dual wheel load assembly is there, and wheel load is 70 kilonewton, and a contact pressure of 0.7 kilonewton per mm square is applied on a homogeneous mass with the modulus of elasticity. Right. So here one more additional thing they are given is modulus of elasticity 12 Newton per mm square. If the center to center distance between the two wheel is 600 mm, determine the deflection value at a depth of 0.5 meter at 4 points at the center of the dual wheels and at the radial distance of 300, 600 and 900 mm from the center along the line of joining centers of the two wheels. Use deflection factor chart. So he is clearly mentioning to use the deflection chart, factor chart. So in deflection factor chart, what will be there to find the sigma z? So what is the given value here? Given value is load he has given capital P, right? Then what else he has given? Small p, the contact pressure, small p he has given, right? So from capital P and small p, what we can find? Small a we can find, right? So next is he has given modulus of elasticity, that is capital E. Capital E he has given. Then what else he has given? That is center to center distance between the two wheels. That is uh, distance between the inner wheels he has given 600 mm. Then determine the deflection factor value at a depth of 0.5 meter. So depth is, so all these values are in Newton or kilonewton per mm. So here he has given in terms of meter. So that we need to convert into mm. So how much? 500 mm is the depth. Z is equal to 500 mm. Next is 4 points. At 4 points, he is asking us to find the sigma z, which is that point. One is exactly center of the dual wheels, right? Where r is equal to 0. Second is radial distances of 300, 600 and 900 mm, right? So he is asking us to find not the stress, he is asking us to find the deflection factor. Delta is equal to
Small
hmm,
PAF divided by E.
very good. Pa by E into F, right? So that is what the deflection formula which you'll be using. So that is also available in your deflection chart. So this is vertical stress distribution chart. Okay, whenever you are referring, you need to just check what he has asked here, whether he has asked us the stress or deflection. Okay, here clearly it is mentioned deflection chart. Okay, for single layer theory in the question he has mentioned that is, here he has clearly mentioned homogeneous mass. Homogeneous mass means a single layer theory, right? So there we need to, okay, deflection chart, this chart we need to use. So in this chart he has given delta is equal to pa by E into f. Okay, so here also what we require z by a and r by a, r by a values. So r by a curves are there. What we'll get? We'll get the deflection factor f, right? So here what all things are known from this formula to find the delta? What we require p, small p, a, e and f. F will get from the this chart. To get the f value, what we require? We require z, a and r. Z value he has given how much? 0.5 meter, that is nothing but 500 mm. Okay, next a we need to find from capital P and small p. Capital P and small p we need to find this a. So one of you can start calculating a value, okay, and tell me the answer. And what is r? R he has given, that is center 0, 300 mm, 600 mm and 900 mm. right? So like this, R values are there. So we need to calculate first A value. That is the first unknown, right? In this formula. Then we can find out delta deflection for various R value, R by A and Z by A values, right? So those who have attended earlier classes, you can start with your calculations. Those who are new, for them, I'll be starting with the basic diagram and calculations. What is the solution for this? Solution is first to draw the diagram. What is dual wheel load assembly? Dual wheel load assembly. One wheel. So this is nothing but your college bus rear tires. One side tire. So both the tires are next to one another. So diagram is not. Both are having same. So this clear distance he has given. How much inner surface between the inner surfaces? It is 600 mm. Right. 600 mm is the inner distance between the tires. This is, and load transferred will be how much? 70 kilonewtons. Capital P he has given as 70 kilonewton. And contact pressure small p he has given as zero point 0.7 kilonewton per mm square. Right. Then this is excess of loads. This is how much to calculate, right? And radius of contact area small a, right? So that is d is equal to 2a. So we require this small a to calculate this distance. This is nothing but 300 plus a, right? So that is distance between center of loading, excess of loading, and the point load where it is applied. And z he has given. Z at what depth he is asking us to calculate? He is asking us to calculate at 500 mm. That is nothing but 0.5 meters. And at this particular point, axis of in the same axis of loading. So at this particular point, how much is delta? And at 300 mm, when it is 300, when it is 600, when it is 900, how much is the deflection at these points? Right? He's asking at these points. What is the A value? Those who have calculated. Will you calculate?
178.41.
170.
8.41.
Okay. A is equal to square root of capital P divided by pi into small pi. So put the values square root of 70. Okay. Once you get, as I have mentioned earlier, so in the for calculation of F, hmm, what we require? Z by A and R by A. But Z is constant. R by A is not constant because R values are different. One is 0, 300, 600, 900. So better to make a table and calculate F different F values. Then we'll calculate the deflection values. So for simplification purpose, what all we require? We require A value, P value, and Z value. Z is 500 mm, constant values, and E value is how much? E is equal to 12 Newton per mm square, right? And we require Z by A, then R value, R by A. Then with respect to Z by A and R by A, we need to calculate F. Z by A is how much? It's constant, no? So it is 500 divided by A is how much? 178. How much you are getting?
2.81, sir.
2 point?
81.
Okay, 2.81 or 2.8 will keep. And R is at R is equal to 0 at the center of loading, axis of loading. It is 0 because it is radially not away. It is in the same line of axis. So R is equal to 0. And R by A is equal to default. It is 0. Right. Then F calculation will go for graph later. Next is when z by e is throughout it is same only. It is z is not changing, so it is 2.8. When r is equal to 300. Hope you are getting the next one.
1.68.
1.68. Very good. Next for 600,
3.37.
3.37. 600 divided by 178. 3.37. Next is 900. How much?
5.06.
5.06. These are the values which we need to. So now when z by a is equal to 2.5 and r by a is equal to 0, what is our f value? This for this we need to refer the chart deflection chart we need to refer. Okay. Well, see at 2.8, see it is 2, it is 3, slightly lesser than this. 2.8 and r by a is equal to 0. This curve, which curve? First curve. R by a is equal to 0. This curve. So where it is cutting nearly this point. This is what? This is nothing but zero point 0.5 or 0.49. Come along this line. It is cutting at this particular point. Go vertically up. On x-axis, we are getting a deflection factor f is equal to zero point 0.5. Just note down in the our calculation table. So it is zero point 0.5. If you want, you can write 0.48 or 0.49. That's no problem. Slight difference will be there. And next condition is when z by is equal to, it is remains same 2.8, and r by is equal to 1.68. I will consider 1.7. Here it is same 2.8. R by a is equal to 1.7. So 1.5, 1.5 and 1 here 2 is there. So we'll have an imaginary line slightly parallel with these two lines, right? So somewhere it is cutting here, right? So that is which point? So that is 0.4. Are you getting? So we need to select 1.7, 1.68, or we will consider 1.7. So approximately an imaginary line we need to assume, and which should run parallel to these two lines. With the pencil, you can mark in the chart and you can refer this, right? So this is somewhere zero point 0.4, right? So that also you note down is point z by a is equal to 2.8, which remains same, and 3.37 or 3.4. So r by is equal to 3 and 4. So somewhere here we'll assume slightly parallel. 3 is 3.5, so 3.4 we'll assume here parallel to this. So here 2.8, it is approximately, so half of this, that is 2.5. This 0.25, correct? 0.25, right? And when z by is equal to 2.8 and r by is equal to 5, how much you are getting? 3, 4 and 5. This line is cutting at this particular point.
0.17.
1.6, sir.
It is between 0.16 and 1.7 because this is 0.15. This is approximately
That is what?
0.175, right?
175,
This
sir.
point. So it is 0.17. You can write. Okay. So this is from chart. So now put the values. Delta is equal to P is how much? A is 178. E value 12 into F. F is zero point 0.5. How much you are getting? This is not kilonewton, it's just a Newton.
2.71. 1.77.
1.77. Here you can observe the deflection is decreasing as you are going away from the excess of loading, right? So if they tell you to write a comment and all, so that time you can just have an observation as we are going away from the excess of loading. So from center, it is when you go away from the excess of loading, it is decreasing. Like that, you need to write the comment. Okay. Any difficulty in understanding? Similar kind of problem I'll give. You can try later because we need to solve question paper problems. One question I had shared in the WhatsApp group.